Hey guys, welcome back to Quantum Tinker. Today we will be discussing what are electrons. Now, by the way, it's Sophia here. Let's start with the basics. What are atoms? They are beautiful, small particles that make up matter. Think of your pet if you have one. Think of yourself. Think of your limitless brain of yours. It's all made up of minuscule particles called atoms. Inside of those atoms are subatomic particles. Think of them as even smaller particles that make up atoms. Imagine breaking the smallest particle of matter into even smaller pieces. That is an electron. Electrons are stable subatomic particles with a negative electrical charge. Electrons sit on shells around an atom. They orbit around the atom. Why do they orbit around an atom? Well, our answer is that it is due to electrostatic attraction, similar to how a magnet, a north pole is attracted to a south pole. Attraction within an atom is made due to the statement, opposites attract. Now, what does this have to do with electrons? With the positive charge, the proton, and the negative charge, the electron, opposites attract. So an electron is pulled towards the nucleus of an atom. Let's talk about electron configuration. The first shell closest to the nucleus can hold up to 2 electrons. The second shell accommodates 8 electrons. The third shell can hold up to 18 electrons, but often stops at 8 before filling the fourth shell. The fourth and higher shells follow the 2n squared rule, where n is the shell number. For example, theoretically, based off 2n squared, the max capacity of these electron shells can hold are in the first shell we have 2 electrons. On the second shell we have 8 electrons. On the third shell we have 18 electrons. Fourth shell, 32 electrons. Fifth shell is 50 electrons, and the sixth shell is 72, based off the 2n squared rule. Now, there are some restraints to that stop the electron shell from reaching its maximum capacity. For example, we have the energy hierarchy and subshell order. Electron filling does not follow a simple fill one shell fully, then move on rule. Instead, it follows the off-bow principle, meaning electrons fill the lowest available energy orbitals first. In the case of iron, for example, atomic number 26, the third shell can theoretically hold up to 18 electrons. However, instead of filling up the 3d orbitals first, the 4s orbital is lower in energy, so it gets filled before 3d. That's why iron's electron configuration with only 8 electrons in the third shell. We also have electron repulsion and stability. Electrons repel each other, and orbitals with similar energies can overlap. Sometimes filling higher energy orbitals first stabilizes the atom more fully than occupying a lower energy shell. This is why elements like iron, copper, and chromium have an unusual electron configuration for extra stability. And thirdly, we have quantum mechanics and Hund's rule. Hund's rule states that electrons prefer to occupy empty orbitals within a subshell before pairing up, which affects how electrons distribute themselves across d orbitals. Take a look into the quantum mechanics and wave behavior. Electrons don't move like planets around the sun. Instead, they exist in cloud-like orbitals based on probability. They occupy specific energy levels, which are shells, rather than fixed paths. The Heisenberg uncertainty principle states that we can't pinpoint an electron's exact location, only where it's likely to be. Now we look at centrifugal balance. If electrons were just pulled into the nucleus, they would collapse into it. So their movement creates balance between attraction and momentum, keeping them in orbitals instead of crashing into the nucleus. Finally, we have the wave-particle duality. Electrons behave both as particles and waves, meaning they don't orbit in the classical sense, but exist in probability clouds around the nucleus. Anyway, this is all for this lesson. So, see you next time at Quantum Tinker. We may even dive into these principles and smaller details in later lessons, where we can finally experience the full holistic sensory of curiosity. See you next time.